We ended our last video looking at how to use SAS to find a confidence interval for a predicted value using our simple linear regression, and then how to interpret that interval once we got it. And I mentioned that we're going to start this next video by talking about doing the same thing for prediction intervals. So remember, a confidence interval is if we want to say something about the population mean response for a certain x value. A prediction interval is if we want to say something about a particular response, so a certain person or object for a certain x value. And the equations look almost identical. I've highlighted the only difference between them. And what this is going to do is, since this is after the plus or minus part, this 1 plus part here is going to make our prediction interval bigger or wider than our confidence interval. And if you think about it, it makes sense that it would have to do that, because it's a lot harder for me to predict how tall a certain person will be than it is for me to predict the average height of everybody. I've got a pretty good idea of how tall people are on average. But if I just have one person and I need to predict the height of, the next person to walk in the door, that's a lot harder. And so I need a bigger interval because my guess probably isn't going to be as close to the correct value. So this 1 plus is going to make our prediction intervals wider than our confidence intervals. And in terms of finding the values, the only difference is instead of putting CLM at the end of this second line, we're going to put CLI. So remember, CLM was confidence limits for the mean. CLI is confidence limits for an individual. So for prediction intervals, we want to know about an individual. And so we can do this same thing for the burger example. Let's predict the calorie content for a particular burger with 35 grams of fat. And I'll just go back to my SAS code here, and I'm just going to change CLM to say CLI, and I will rerun this part of the code, and it should look almost identical to what we got before. The thing that's going to tell us that we've done the right thing is that now this says 95% confidence limits for individual predicted value. So remember, before it said 95% confidence limits for mean. Now it says individual. All right. And again, since I want a prediction for burgers with 35 grams of fat, I'm going to look and see that my fourth burger in my data set is the one that has 35 grams of fat. So I will go to my results. I'll go to observation 4, and this line is the one that has my prediction interval. So my 95% prediction interval would go from 483.2 up to 685.3. And if you go to the notes, that should be what we see here. And so my interpretation would sound similar, but now I'm saying that I'm 95% confident that a particular burger with 35 grams of fat will have between 483.2 and 685.3 calories. And this is different from before when I said I was 95% confident the population mean number of calories for burgers with 35 grams of fat would be in between some range. So there might be one other thing that you're still sort of wondering, which is, this is great if we want to make a prediction for one of the actual x values we've already seen, but what if we want to do it for something else, right? If I go back to SAS, I could make predictions for burgers with 19, 31, 34, 25, 39, or 43 grams of fat. But what if I wanted to do this for 40, or 32, or 27, or whatever it might be? Right now, I don't have a way to do that. And we're going to learn a little trick here. It's called the missing y trick. And basically what we do is we can make a prediction for any x value. And all we have to do is add that x value to our data set, but it's not an actual burger in our data. We don't know the number of calories. That's the thing that we want to know. And so what we'll do is we'll just put a period where our y value would be. And this is the way that we write a missing value in SAS. And so we're essentially saying, we've got this extra burger, it's got 28 grams of fat, we don't know how many calories it has. It's not going to change any of our actual like estimated slope, estimated intercept, r squared. None of that will change. The only thing that's going to change is now when we ask for a confidence interval or a prediction interval, we will get one for this value as well. All right, so I'm going to go to my code. I'm going to add a burger with 28 grams of fat, and then I'm just going to put a period here. And let me get rid of the confidence interval part and just rerun all of this. And what you'll see is that it says that it read in 8 observations, but it only used 7 of them. So hopefully this intercept and this slope look familiar to you. Nothing's changed here, all right? But let's say that I want to generate a confidence interval. Well, now I'll go back here and I'll add /CLM and I'll rerun this part. And you'll see that I will have an 8th row in my confidence intervals. And it doesn't tell me what the observed value was because there wasn't one. Can't calculate a residual either because we don't have an observed value or an actual value. But I do have a 95% confidence interval. So the population mean number of calories for burgers with 28 grams of fat, I'm 95% confident that that's between 453.3 and 547.9. All right? And if I go back here, you'll see that that's what we got. If I wanted to do a prediction interval, I will do the same thing. I'll change this to say CLI instead of CLM. And I'll run my code. And again, I've got this 8th line, and this here would be my prediction interval. So I want to point out one other thing. Let's say that I've got a data set that has 300 observations in it. Now, it might be really hard for me to find a specific X value that matches up with the prediction that I'm trying to make when I'm looking through this table if it has 300 things in it. And so we can actually use this missing Y trick even if we already have an X value in our data set that matches the one we want a prediction for. So this is actually a nice trick for just any time you want a confidence interval or a prediction interval. But getting ahead of myself, so if I go back here, here is my prediction or my interpretation for my prediction interval. And just to sort of wrap up this difference between confidence intervals and prediction intervals, remember that prediction intervals are wider. It is harder to predict a single value than it is to predict a population mean, and so we need a wider range for our interval. And just because maybe you're curious, I said that we were doing a prediction for the Big Mac, which has 28 grams of fat, and in this case it looks like our prediction interval actually worked. The Big Mac has 540 calories. That is inside of our prediction interval, so it did the trick here. So this is actually where we're going to end for new material for the semester. As I mentioned, normally we would talk about something called multiple linear regression, where we have more than one explanatory variable. So maybe I don't just use grams of fat to predict calories. Maybe I use grams of fat and grams of or carbs or something like that. And that would probably give me a better prediction. The reason I'm saying this is just because I want you to know that this may be something you encounter in the future, and a lot of the same ideas will apply. All right? So if you made it all the way through this video and all of the other ones, thank you for doing that, and let me know if you end up having any questions.